All right, today we're going to break down what is honestly the single most important concept in all of artificial intelligence. It's this hidden blueprint behind pretty much everything: smart assistants, self driving cars, you name it. It's called the intelligent agent. And once you get it, it really changes how you see the world of AI.
So let's just dive right in with a little puzzle. What on earth could possibly connect beating a chess grandmaster, planning a super complicated day of errands, and a baby learning to talk for the very first time? I mean, they seem totally, completely unrelated, right?
And yeah, on the surface, they're just worlds apart. Proving a theorem? That's pure logic. Finding a screwdriver is all about visual search. A baby learning a language is, well, it's magic, basically. And planning a trip is just strategy. But, for AI researchers, there's a single powerful idea that links all of them. An idea so fundamental, they've built the entire field around trying to replicate it. And the answer is actually really simple. They are all tasks done by an agent. And this right here is the part that just blew my mind when I first learned about it. See, before this, people were trying to program thinking or learning as these separate, abstract things. But framing it all in terms of an agent gave them one model for any kind of intelligent behavior. It was a total game changer. So, what even is an agent? Well, the official definition can sound a little academic, but the idea behind it is incredibly simple. An agent is just anything that can sense the world around it and then do something about it. It perceives and then it acts. That's it. That's the whole game. And this is where it all just clicks into place. We are agents. Our eyes, our ears, our sense of touch, those are our sensors. Our hands, our legs, our mouths, those are our actuators, the things we use to take action. A robot is an agent too. It just uses different gear. Cameras and GPS for its sensors, and motors and wheels for its actuators. But it's the exact same principle. Okay, so knowing what an agent is one thing. But how do AI designers actually build one that acts intelligently, or what they call rationally? Well, they don't just jump in and start writing code. They start with a simple but really powerful blueprint to map out the agent's entire world. And that blueprint is a little framework with a super memorable acronym, PEAS. You can really just think of it as a checklist, 4 essential questions that a designer has to answer before they can build any intelligent agent, whether it's a simple chessbot or a complex self-driving car. So, PEASS stands for Performance, Environment, Actuators, and Sensors. The designer is basically asking, first, what does a win look like for this agent? That's the performance measure. Second, where is this thing going to live and work? That's its environment. And finally, what tools does it actually have to see the world and then do stuff in it? Those are its sensors and actuators.
So let's make this real with a self-driving taxi. What's its performance measure? Well, getting you there in a safe, fast, and profitable trip. What's its environment? The totally chaotic world of roads, traffic, and pedestrians. Its actuators, the steering wheel, the brake, the accelerator. And its sensors, all the cameras, GPS, and sonar. See how that works? Every rational agent can be broken down this way.
Okay, so now that we have the blueprint, let's kind of pop the hood and see how these things actually work. Because not all agents think the same way. They can be incredibly simple, almost mindless, or they can get surprisingly complex in their reasoning. At the very, very bottom of the ladder, you have the simple reflex agent. This guy is as basic as it gets. It has zero memory, no concept of the past or the future. It just follows a simple, hard-coded set of rules. If you see this, then do that. End of story. And you really can't find a better example than a simple robot vacuum. Its entire brain can pretty much be boiled down to one rule. If the spot I'm looking at is dirty, turn on the vacuum. It doesn't remember where it's already cleaned, it doesn't plan a route, it just reacts. Simple, yeah? But for that specific job, it works perfectly. But obviously, that simple reflex approach only gets you so far. I mean, imagine if our self-driving taxi worked that way. It could stop at a red light, sure, but how would it ever figure out how to get to a specific address all the way across town? For that, you need a goal. And this is where we start to level up to more advanced agents. You've got goal-based agents, which can actually plan. They know their destination and can figure out the steps to get there. But then you have utility-based agents, which are even smarter. They don't just find a path to the goal, they find the best path. They weigh all the trade-offs, asking, is the faster route through heavy traffic better, or is the slightly slower but safer one better? It's trying to maximize what's called its utility. You can almost think of it as its overall happiness score. So here's a really crucial point. An agent's intelligence isn't just about its internal programming. The kind of agent you actually need, whether it's a simple reflex bot or a super complex planner, is totally determined by the kind of world it has to operate in. The harder the environment, the smarter the agent has to be. For example, think about a chessboard. That environment is fully observable. The AI can see every single piece on the board. There are no secrets. But now think about a game of poker. That environment is partially observable. The AI has no idea what cards its opponents are holding. It has to make its best guess and strategize with incomplete information, which is a much, much harder problem to solve. And it's the same exact thing with predictability. Chess is deterministic. You move your knight, and the outcome follows a clear, set rule. But driving a taxi is stochastic. It is completely unpredictable. Another car might swerve for no reason. A pedestrian might step into the road. The agent has to constantly react to pure randomness, and that is a huge, huge challenge for AI. And this really is the key takeaway. The real world, the one we all live in, and the one we want AI to help us with, is the hardest environment of them all. It is full of hidden information, it's random, and it's always changing. Building an agent that can actually thrive in that world, well, that's the ultimate goal. And it's what makes this field so incredibly difficult and so fascinating. So I'll leave you with this final thought. We have gotten incredibly good at building agents for these closed, logical, rule-based worlds like chess. We've mastered that. But what's the next frontier? Can we build an agent that actually understands nuance and creativity and human intent? Can we build one that can tell a genuinely funny joke on purpose? Now, that is the question that's going to define the entire next chapter of AI.